How's it going, friends? Let's take a look. Today, our goal is to solve equations with variables on both sides and relate those to the world around us. Let's get it. Here we go. First question here. Some equations have variables on both sides. Okay, question one. Let's take a look at this. We've got a chart there on the right. Take a look. There's a chart, so we should read it. Comparing theater A and theater B, a ticket price, and popcorn. Some friends want to see a movie they're showing at two different theaters in town. They plan to share 3 tubs of popcorn during the movie. Okay, so there's a number in there. When we read word problems, we want to pick up the number 3. 3 tubs of popcorn during the movie. Okay, which movie theater should the friends choose? All right, so when we're going about this, we have 3 tubs of popcorn. We know that there's going to be that thing times 3 and this thing times 3. Wait, 2 different theaters in town. Some friends. We don't know how many friends. So this is going to be, so when we talk about the friends, we've got like $14.50 times the amount of friends. So number of friends. When we're talking about like how much money are they going to spend? So that's a question. So let's look at the question. Here we go. So we have this question like which movie theater should they go to, but then we don't know which one's going to be more expensive for a certain amount of friends. Like what happens if there's 100 friends? Which one's going to be more expensive? What happens if there's 2 friends that are going? Hopefully not 100 because we're only allowed to have 50 people in a room, right? Isn't that a thing? Anyway, so we need to figure this out. We need to relate those things. So we can write an expression for like theater A. Theater A. Say theater A would be like $14.50 times the amount of friends, number of friends going to the theater, plus, and they're only going to share 3 tubs of popcorn. And when we read it, we're like, maybe there's only 3 friends, but it doesn't say that. So there could be 100 friends sharing, or 50 friends sharing 3 bags of popcorn. We don't know. Theater B is going to be a very similar setup. So B would be 13 times the number of friends plus like $6.75. And the question is, when are those things going to be the same? When are they going to be the same? How do we do that? Well, we can take those 2 expressions. Let's just make it F, right, for number of friends. So let's simplify 14.5 times F plus 5.75 times 3. 13F plus 6.75 times 3. Okay, so when are those going to be the same? Well, we're going to turn around and set them equal to each other, and that'll tell us when those 2 sides would be the same and equal, and that'll tell us, the kind of the even point, the break-even point on which one we would do at which time. So here we go. I'm going to simplify this while we're at it. I'm going to type it in my handy-dandy calculator. So we got 5.75 times 3, 17.25. 17.25 plus 14.5 F equals 13F plus 6.75 times 3, 20.25. And we go ahead and solve this. So we need to figure out how to go ahead and solve a problem like this. Oh my gosh. Well, here's the rule of thumb. Essentially, you want to collect the variables on one side and the numbers on the other side. And when you do that, then you can solve it like we've done it in the past, which is totally awesome. We're going to take this problem and turn it into something that we've done before, which is what we do in math. So that's what we're going to do now. So we want to get the variables to one side and the numbers to the other. I prefer to always move the variables to the left. That's just my deal. Some people like to always keep it positive, but I don't, that's their thing. So I'm going to move this 13F to the left first by subtracting it, and that's going to move that thing to the left. So we get 1.5F plus 17.25, let me zoom in, equals 20.25. Then we subtract 17.25 from both sides, and we get 1.5F equals 3. Divide by 1.5, and we get F equals 2. What does that number mean? Now, that number means the number of friends at the break-even point. So one of the theaters is going to be cheaper with 2 friends. The other going to be cheaper with 1 friend, 2 friends, And then with 3 friends, the other theater is going to be cheaper. So if there are 3 or more friends, let's look at this. Which one's going to be cheaper? Theater B is going to be cheaper, even though the amount for the cost of popcorn is more. That's okay. That's the problem. All right, so here we go. That's kind of an application of what we're doing, why we're doing it. Let's get into the nitty gritty of a specific problem. So again, I like to move variables to the left first. So minus 3x, minus 3x. We get 30. Negative 9 minus 3 is going to be negative 12. So we get negative 12x equals 6. Then we're minus 30. Minus 30, move the numbers to the right. Negative 24. Now we're going to divide by negative 12 and we get x equals 2. Yeah, let's do it. What I want to show you now is that you could get the same result by doing it the other way. So if I move this to the right by adding 9x, right, 30 equals 6 plus 12 minus 6, and we get 24 equals 12x. Divide by 12 on both sides, and we get 2 equals x. Check it out. We get the same thing on both sides. It's awesome. Which one seems easier? I personally believe moving everything to the left is easier because it's just one little process. But the one thing you need to pay attention to is you might get this negative up here that you have to deal with and the negative there. So like there might be sign errors. So sometimes teachers like doing it a little bit different. I like to always move it to the left. Variables to the left, numbers to the right. Let's do the next one. Okay, circle the terms that you would move first when solving. So when I'm looking at this, I want to decide which one do I move first. I always want to take this and move it to the left. So I'm going to be consistent on that, on all the problems. This one gets a little funky because when we take this and move it to the left, watch what happens. I'm going to do this problem. So when I take that and move that to the left first, some students will get super confused as to what happens on this side of the equation. That is still a side of an equation, so keep it. You want to make sure negative 3x minus 3x is 0, so you got to leave it there. You don't just, the equal sign doesn't just disappear, and it doesn't get dropped in between these two. That would be bad, because that's a number, like 3x minus 3x is 0, so like that's a thing. So anyways, that's always a trap when you do it the way that, oh, it's interesting. You get x is 1. Might as well finish it. All right, take a look at number 5. Here we go. We're going to move this to the left because that's the way I do. 8 minus 2c equals negative 2. Now we're going to move this to the right. 2c, negative 2c equals negative 10. I'm going to divide by negative 2. Divide by negative 2. We get c is 5. Get it? Next one. Pause it if you need more time. Oh, this is a review problem. This doesn't have variables on both sides. There's only a variable there. But we want to focus in on where that variable is. And what's happening? We have the times 5, and we have the minus 4, and then we have this divide by 10 that we need to get rid of. Which one's furthest on the outside? Furthest on the outside to get rid of. It's the divide by 10. So we're going to multiply both sides by 10. It's opposite divide. So those two cancel. So we get 5b minus 4 equals now 4 over 5 times 10. It's going to be 4 times 10, which is 40 over 5. We're going to keep going now. Now we're going to add 4 to both sides. Add 4. 40 over 5 plus 4 over 1 is going to be 40 over 5 plus 20 over 5, which is 60 over 5, which is 12. So we get, 12. You know what? I paused there. You know why I paused? Because 40 over 5, I should have just reduced that. I should have just reduced that to 8 right there when I had the chance, but I didn't feel like it. Anyway, so now we're going to divide by 5. So we get v is 12 over 5. There it is. At this step, I could have gone 5v minus 4 equals 8 and then added 4 because 40 over 5 is 8. I didn't realize that right away, but it's okay. It's still got the right answer. Good. Next problem. Okay. Essential question. Here we go. How is solving an equation with variables on each side similar to solving equations with variables on one side? It's kind of the same process. You're going to move things. If you move things from one side of the equation to the other, you have to do the opposite sign to move them over. How do you go about clearing fractions in these equations? You can. We're going to ignore that question because we didn't really do that in class for us. All right, let's do a question where we have fractions distribute. So we're going to do 5/8 times 16 and we get 10d. 5/8 times 24, and we get 15. Over here, 6 times d, 6d. 6 times -1, -6. 6 times +1, +6. Oh man, let's combine like terms on the right. Let's simplify it. So these two simplify, and that's 0, so we get 6d over there. Over here, we get 10d plus 14. Now we have this little tricky situation where if we're going to move it to the left, -60, -60, -60, we get 4d. 10d minus 60 is 40 plus 14. But over here on the right, we can't just get rid of that side of the equation. We got to keep it. It's 0. Sometimes folks are tempted. It gets weird when it's 0. People are like, 0 is not a number. I shouldn't use it. Anyways, don't do that. And don't just like drop the equal sign in between these two for fun. All right, let's move these to the right. So we get 4d equals -15. Divide by 4, we get d is -15 over 4. Let's get it. All right, one more question, then we're done. Let's do this. You can do it. Distribute 100 times k would be 100k. 100 times 0.2, move the decimal twice. -20. -10 times k, -50k. Negative times 0.8 would be -80. Keep going. Move the variables to the left. That's the way I do. So 50k minus 20 equals -8. Keep it going. Add 20. Add 20. 50k equals 12. Divided by 50 here because it's 50 times k. So we get k equals 6 or 12 over 50, which is 6 over 25. Everybody say hi to Miss Quiggy. Hi, Miss Quiggy.
Hi.
She's loving my voice. There we go. Well done. Peace.